Good morning, everyone. My name is Marina. I'm also a member of the organizing committee, and I'm very happy to introduce now Susanna Tron, who is a natural language understanding chapter lead at Swiss Re. Susanna, the virtual stage is yours.
Thank you very much, Marina. Hi, everyone. Thanks for having me. So as Marina just introduced me, I'm Susanna. I hold a master's degree in computational linguistics from University of Zurich. And I've been working in the industry since roughly 7 years now, most of which in the insurance industry at Swiss Re. And today I would like to give you also a bird's eye view on another type of unstructured data, namely language. In particular, how we can use it in reinsurance. So first of all, I would like to start very briefly with explaining to you what is reinsurance, as not everyone might have come across this term before. Very simply put, reinsurance is insurance for insurance companies. So at the bottom here, it's you and me. We are owners of properties such as cars or homes or other things that we need to insure against unexpected events, such as damage, loss, or theft. And for this, we make use of insurance companies. Now, in case of larger events where there are many losses and many payments that need to be done by the insurance companies, they can themselves refer to reinsurance in order to be able to do these payments and not to get into financial difficulties themselves. And so, for instance, if you think about what you hold in your hands when you buy an insurance product, it will typically be a contract. When you have to file a claim, you will most probably fill in a form, either written or so on paper or on the internet. So again, you will produce and submit a document. And this is what what also is characteristic of the reinsurance industry is that it's a very document-centric and document-heavy business. So along the whole value chain, you will have some type of documents. Usually it's very large documents. And our business processes all evolve in one way or the other around some type of documents. And this is then where natural language processing comes into play by means of NLP enhanced tools. Our business experts can be supported in their day-to-day tasks. For instance, by spending a bit less time looking for information and more time with analyzing and dealing with the information and for decision-making processes. So on the one hand, you have the time-saving perspective that is important, but there is more. So with NLP, we can generate new insights, so we can tap into a huge amount of unstructured data and maybe identify any patterns, any new risks. And similarly to that, with NLP, we can also do risk mitigation of some kind. So for instance, we can enhance or build reviewing tools that will help, again, the human reviewers spot more easily and quicker problematic places in a contract, for instance, where we have unwanted coverages or unwanted terms and conditions. So we do a lot of NLP, and more particularly NLU in reinsurance. Being mindful of the quite diverse audience today, I would like just to spend a very few words on what is natural language processing and also why is it actually quite challenging. So I like to, also to simplify a little bit, I like to often describe NLP as a subdomain of artificial intelligence dealing with teaching computers to learn and to generate human, also called natural language. So if you think about, this is just a short list of possible applications of NLP that you might actually be using in your day-to-day lives, at work, or in private lives. So very early ones are spell checkers, for instance. You have spam filtering, language translation, an area where there has been a lot of very big advances in the last years. And also things like sentiment analysis, where, for instance, you have a lot of written reviews on an online portal, for instance, and you would like to be able to classify them into good reviews and bad reviews, for instance. And then last one here on the list, also an area where there has been a lot of advances in the recent year, are virtual assistants. So typically on our phones or in the form of more or less helpful chatbots on some websites. This is also a type of application of NLP. And I would like to just remain a second with the virtual assistants, because so often when we talk about NLP, we include, or we actually mean, sub areas of NLP, which are often not really separable from each other. So on the one hand, you have natural language generation. As the name says, it's the area, so the domain where you teach computers to generate language. So your chatbot or your virtual assistant that is able to produce well-formed, meaningful language. And on the other hand, you have natural language understanding, which might come right before or after the generation, which is the ability of machines to comprehend human language. And so today I would like to focus on natural language understanding of written, in written form. And before I move to an example that we have within Swiss Re, I would like to spend a few words on why is this area, so NLP in general, but particular natural language understanding, is still a quite, so consists of many tasks that are still quite difficult to solve despite recent advances in the fields. So why is, in particular, natural language understanding difficult? If you think about your language lessons when learning a new language, or even back in school, the language lessons that you did on your native language, human language is made of many layers. I will skip, for the sake of brevity, the first three ones, where we're more at the sound and word level, and move to the syntax level, so to the sentence level. So there are different rules that form the syntax in some languages. So for instance, in English, we have a quite easy construction, which is subject, verb, object. So this is the rule. But then, so you can generalize, of course, fairly over this. However, this is the theory, and in practice, you will not always have well-formed sentences. However, so take, for instance, non-native speakers, they might do some errors in the structure, but still it is meaningful and understandable. Conversely, you might have well-informed sentences that are, however, more or less or completely meaningless, like in this case here. So this is where semantics comes into play. So semantics is the study of meaning. And again, you can, of course, generalize to some extent, but it is also still something quite difficult to model for machines to mimic. So for instance, for us humans, it's easy to understand in a given sentence whether call is a verb or a noun. And of course, you can refer to some extent to the structure of the sentence, as I showed before with syntax. However, even if you have the same word at the same place in the sentence, so two nouns, you still might disambiguate further given the surrounding context of the sentence. So is it virus as in a computer virus or another type of virus? Then if you take this even further at the sentence level, you have things like situations where it's about disambiguating, like here. So this is a typical sentence used to test the ability of algorithms to understand. And for us humans, it's easy to understand that it and big refer to trophy in the first sentence, thanks to our common sense and the knowledge of our world. However, this is still something quite difficult to solve. And last but not least, you have pragmatics. So this is also the ability to understand meaning in a wider context. So for instance, to understand whether a sentence is meant in an ironic way or not. So again, for us, it's quite easy, but this is difficult to model or to mimic for a machine. So I would like to focus on semantics. So really the understanding of written text in our domain-specific application. So at Swiss Re, we have, amongst others, an in-house contract reviewing tool that was built quite some years ago by and for lawyers to do certain reviewing tasks. It is based on a large database of clauses, most of which are in English, but actually it's a multilingual database. And not only do we capture the text, but also other information. For instance, is this a good quality clause? To which markets does it apply? To which areas of business do they apply? And so on. And so the main feature of this tool is, given a contract, for each clause in the contract, we want to compare them against the clauses in the database and determine how similar or not these clauses are, and in order to then decide whether this needs further review or maybe it needs to go back to the client for modifications and so on. So for the similarity, so for the comparison of a detected clause, so far the approach was character-based. So basically, so here you have two clauses, you overlay them and you compare the sequence of characters to determine how similar they are. And as you see in this example here, it's a solid approach because you will easily see what has been changed and also the overall score suggests that there have been quite some changes that you need to look to take a closer look to. However, you might have cases like these. If you look at the score, it's very comparable. However, if you take a closer look at the differences, you will notice that you have basically some variations in the language. You have the use of synonyms, a slightly different way to express the same things. And those are so-called non-material changes, which in this case are not relevant for the review because semantically and also legally, this clause is doing the same thing and wouldn't need any further review. So to avoid these cases, so on one hand, to avoid spotting non-material changes, on the other hand, to have the possibility to actually spot material changes, for instance, the insertion of small words that make a big difference, like not, we decided that we needed to enhance this comparison with semantics. So how did we decide to do this? So first of all, to do a semantics-based approach, you need the possibility to detect synonyms and related words. Then you need to define how you want to implement legal similarity, because legal similarity doesn't always equal semantic similarity. And then when you do, again, this comparison step, you also want to take into consideration business knowledge in order to mimic as much as possible a human-like comparison or review. And so especially the first one, in the first case, so it might sound straightforward. You can just detect words and that are interchangeable. However, and this is almost a talk on its own, so legal language is very complex, very peculiar. So yes, you might have cases of one-to-one replacement, but you might have other cases where it's rather one-to-many or many-to-one, let's say, replacement or synonymy. You might have something that is also quite peculiar to legal language, redundant expressions, which do the same, but simply, let's say, amplify. And then also different ways, sometimes quite ambiguous, to express negation. So these are all things that we need to take into account. So how did we implement this semantic approach? We started with building a domain-specific ontology or knowledge graph. So we here it's basically building a terminology database of legal language as used in our reinsurance contracts. And we also so have the synonyms, the spelling variations, and most importantly, the semantic relationships amongst these words, for instance, broader and narrower terms. Then this knowledge graph is used to do a so-called semantic abstraction or semantic enrichment of our text. So given a sentence, for each entities, we will identify the concept in the knowledge graph and let's say assign it to the entities. And then in the third step, we will apply a custom edit distance to the sentences. So for those of you who are familiar with Levenstein distance, it's quite comparable. So we will take into consideration the number and type of edit operations, insertion, deletion, and replacement. And then with help of the knowledge graph, we will also take into consideration the weight of these edit operations. So for instance, if you replace a word by its synonyms, it will have a different impact on the overall score than if you replace it with a word that is further away in the knowledge graph. So how does this look in practice? So again, if we take an example with a character-based approach, you can see here two clauses that are on the character-based level 90% similar. This is an interesting case because 90% is often considered as high enough and which doesn't require further review. So this might be skipped also because the original rating is green and no risk clause. And if you scan quickly over it, you will see, well, there are some differences, a few letters here and there. I can move on. However, if you move from the character level to the word level, to the semantic level, you will see that you have a lower score. So this would correctly prompt further review for the contract expert. And you will see that, yes, we had only a one-letter change. However, semantically and also legally, this has a quite significant impact because we have a so-called inversion of roles, which is something that you want to detect because essentially it will make a big difference on who pays what. So this is something that we are now able to successfully detect thanks to a semantic approach. And we have, so this is our semantic similarity algorithm has been in place for 1.5 years now in production with an increasing user group. So I would like to close my talk here. So just to summarize, what I wanted to talk about today was what is reinsurance and how and why do we use NLP? Why is NLP a challenging area, but I think also a fascinating one, especially the NLU one? And I wanted to show you how a knowledge-based semantic approach can solve domain-specific NLU problems in the reinsurance domain. Thank you very much and happy to take some questions.